So, hi, welcome everybody, and welcome to DevSecOps, Paving the Way for End-to-End Security. This is a joint presentation between Trend Micro and Snyk. So, first of all, who's Snyk and who are Trend Micro? Snyk are a world-leading provider of developer-first security. So, 400,000 developers today log into Snyk and use them to find vulnerabilities in their code and help remediate those vulnerabilities. Snyk are a world-leading provider of vulnerabilities in open source libraries. They do a lot of research in this area. And I think they like to say they are security for developers by developers. And who are Trend? So Trend are a 30-year-old pure play security player. So one of the stories I love to tell about Trend is that our first developer, Eva Chen, is now our CEO. She leads the company. We're a very technical company. She leads the company today. We are involved in all sorts of elements of security. Security is what we know and love. And today, what we're telling you about, or what we're introducing you to do, is how Trend are playing with world-leading partners like Snyk in the world of DevOps, container security, and the new reality for security in the way we're delivering IT. Just some housekeeping before we start. So there's a Q&A button. If you want to ask questions, just type them into Q&A, and we're gonna talk about those later. Then there will be a recording after we finish, so you'll get a copy of the slides and a recording in an email afterwards. Right, so without further ado, we'll get started. So Alyssa Miller, who's joined us from Snyk, she is a security advocate at Snyk. She application security advocate, and she specializes in application security. She's a hacker, she's a researcher. She's got a great Twitter profile, so you can look her up on Twitter. And she joins us from Snyk. And on the Trend side of things, Will is joining us. He's the DevOps specialist in the technical team in ANZ. And he has a love for DevOps and a love for security. And they're going to help present here today. My name is Mick McClooney. I lead the Trend Micro technical team for ANZ. Okay, so let's go. So first of all, I think that the key thing is that a digital transformation is reshaping the way businesses develop and deliver software and how it's built. And that's to do with DevOps, it's to do with cloud, and the way cloud computing is actually changing the way you do things. And a really good example of this is a company that we purchased recently called Cloud Conformity. They're born in the cloud, but if you imagine you were starting a software company today, you do things completely different to the way you did 30 years ago. And that has lots of benefits, but it also has challenges. And some of those are security challenges. And one of those security challenges is that security needs to keep up in this new world. And you need a new approach to scale security to work the way in which development of software is working, which is multiple releases a day, a full DevOps life cycle. So I think, things are rapidly changing. And before we get started, let's get into a polling question around this, actually. So Alex will bring up a polling, the polling for the question here. So you should see poll 1. So who do you feel bears the primary responsibility for security of the application code? Is it developers? Is it the security team? Is it the operations team? Or, is it something else? Is it other people? Is it some other combination? So if you all want to see if you can vote on that, and we'll leave that a second, see if we can get some results of that vote. I think this is trying to get to the core of what we're talking about today. Who's responsible for security? How can you become responsible for security? And really about the place of security in modern software development. clearly, I think, and about the changing challenges, you know, the way it used to work and the way it now needs to work. So we finished the poll there. There we go. We got 6 to 70% of you think it's the developers. 27% think it's the security team. 4% think it's the operation teams, and nobody chose the other combinations of that. So that's a great result. I think Alyssa and Will, we've got some great things to talk about there. So let's close that poll. Thank you very much for contributing there. We've got two other polling questions throughout the presentation. So thank you very much for that. I think that's going to inform some debate later on. So going back to where we are, this is a slide that shows how we've changed in the way we're delivering software. You know, we used to build physical servers. VMware came in about 10 years ago. Virtual desktops. Cloud is now a really big thing. You wouldn't do, you know, nobody's, you know, producing software and making scalable software is all about cloud. So cloud development and containers, and then obviously serverless. So we're changing rapidly in the way that we deliver software. And that has come with a lot of challenges. And people are using, to a certain extent, they're writing less code, they're using more open source libraries, and that's a good and a bad thing, right? It means that if you write less code, there's possibly less security holes in that code, but then you're using other people's code, so what's the problem there? And how do you trace the dependencies? What we also see is that developers are shifting right in the whole development lifecycle. So they're pushing more, they're taking more control of the cloud and the delivery and the infrastructure and infrastructure as code, and, you know, driving really to the far end of what used to take several teams. Developers are taking control of that. And at the same time, security needs to shift left to meet the developers at the other end. So the security is really built into the beginning of the life cycle and thought about at the beginning. And this is tendency what we're seeing. And what we're going to talk about is how security can shift left and be frictionless and work with DevSecOps in a way that's going to really secure things early on and not chuck up a security gate later that says, oh, no, you can't release that code, but more about working earlier on to define and iron out the problems earlier. So I'm going to hand over to Alyssa now, and Alyssa can talk about these things. Here we go. Over to Alyssa. Thank you.
Well, thank you, Mick, and hello, everybody. It's great to have you here with us today. And so Mick kind of mentioned already what that changing environment looks like as we're moving into more of this DevSecOps pipeline. And where that all begins is in our software development. So if we think about the complete software delivery pipeline, it's changed immensely starting from the very beginning. When we used to think about application security, we thought about our code. Our code was something like this. We had 100,000 lines of code, and indeed our developers had written 100,000 lines of code. And so we knew what was in our applications. We were the ones that were responsible for it. We could work with our developers to design each and every aspect of that system. And that's what we did. We worked oftentimes in these waterfall approaches where we had, you know, long cycles of requirements gathering and design work, and the design work turned into different specs, and those specs became ultimately code. And we understood what it was that we were implementing, and it was a solid piece. We owned all of that. But what's happened as we've moved into this DevOps world, where now we've started to develop this culture that gives developers the ability to move quicker. Ultimately, when we think about DevOps, so often we think about just the speed at which development and delivery occurs. And that's when we get into things like the CI/CD pipeline, where we're talking about continuous integration and continuous deployments. And as part of that, what's enabled that is this whole idea of open source software, open source packages and libraries. And so the reality as we see it today is that those applications that 100,000 lines of code that it makes up our particular application, our developers may have only written 10,000 lines of that. The other 90,000 are external dependencies that they've brought in and included as a part of that application to speed their development. Why reinvent the wheel when there's libraries out there that I can pull in that are going to do all that heavy lifting for me? And I don't have to worry about that as a developer. How do I create these different pieces of functionality that I want to add to my particular application? So unfortunately, what this does is this creates some challenges for us. So when we look at an example, so this is one application that we picked out of a repo, and we look at this application. You can see the developers wrote 80 lines of code, and those 80 lines of code, yeah, they're spread across about 3 Java files. But what you see here on the right is that list of dependencies. Now I can look at that and I can say, oh, all right, well, my application is dependent on the Spring Boot framework, and I can see a couple of different pieces under there. I've got a JDBC library, a web library, there's a browser library. Okay, this all makes sense. The issue is, those are just my 7 direct dependencies. Every one of those dependencies has their own dependencies. And indeed, in this example, those 7 direct dependencies turn into 59 additional dependencies when I walk through what packages those packages include and the packages that they include, and I start to walk that dependency tree all the way out. And the reality is that 80 lines of code suddenly turns into 713,000 lines of code. So trying to understand what is all part and parcel to our application becomes very obscured, and it's far more difficult. So as we look at the ecosystems that our developers are using today, we see that it's a mixed bag as far as what we can expect in terms of those dependencies. But indeed, some of the most popular ones, and this is from our State of Open Source Security report that we published last year, and we did research on the various packages that were a part of these different ecosystems. So you've got NPM, and you can see NPM leads the way, where these direct dependencies have large numbers of indirect subsequent dependencies that really explode the size of our applications. Anybody who's developed in Node knows that you go out there and you pull down an NPM project, and the first thing that happens is it sits there and it's going to download those dependencies, and you sit and you wait and you wait, and you go get your coffee, you go get something to drink, you go get some tea, whatever it is, and then you come back and you wait some more, and then finally all your dependencies have loaded. This is why, because we see that simple GitHub repo that we pulled, once we put that into our IDE and we have to load all that, there's a lot to be pulled in. And so what happens here when we start to look at vulnerabilities then is we see that 78% of the vulnerabilities we're identifying, they come from those indirect dependencies. So those are vulnerabilities that are being discovered in software you don't even know is a part of your application. And as a result, within our database here at Snyk, we've got over 10,000 unique known vulnerabilities across these ecosystems. So as we look at those ecosystems and what's happening in terms of vulnerability overall, it's not surprising to see this just crazy amount of growth in terms of vulnerabilities that are being discovered. You see in particular here, Maven leading the way, but you also see, again, NPM with a significant uptick in the last couple of years. Python's been a little more steady rate, but they're all increasing. And as we start to look at these ecosystems our developers are using, and we know that these vulnerabilities come from these direct or indirect dependencies that we don't necessarily know are a part of our software, seeing this type of trend is very concerning, because each one of these, as that grows, means that many more vulnerabilities that are unknowingly being introduced to our applications. And those packages may not be vulnerable the day that our developers write that code and they import that new dependency. These can be vulnerabilities that are discovered 2 and 3 years down the road. So if you're not aware that that dependency is there, how do you get notified, or how do you become aware that there's a new known vulnerability in something that's a part of your software? That's very tricky. Now, but Mick talked before about how developers are moving right. Yeah, as we continue to build in this world of DevSecOps, and we're moving more into these cloud native environments and so forth, the use of containers has taken off to almost exponential levels. And what we find when we start to look at the containers that our developers are using is the concerns exist there as well from a vulnerability perspective. These base images contain just massive numbers of vulnerabilities. You can see that the number of OS vulnerabilities within these Docker images these are just some of the top Docker images out there. The number of vulnerabilities that exist within each of those images can be pretty scary, especially when we're looking at Node in particular. I mean, I'm not trying to pick on Node and my friends in the NPM world, but the reality is there's a lot to be concerned with here. And what we see is that 44% of the vulnerabilities in these base images can be remediated just simply by updating the base image. But what's getting deployed today, and we see it in terms of what we hear about in the news as far as data breaches, is these Docker images are vulnerable. And we have the opportunity to do a much better job in securing them. So how does Snyk play into all of this? So Snyk is here to help you understand that dependency tree. We build out essentially what you could refer to, if you've heard the term, a software bill of materials. So really understanding not only what your dependencies are, but then understanding what dependencies come from under those. Then we're able to look at those dependencies and tell you exactly where you've got vulnerabilities. But we don't just look at them today. We continue to monitor those dependencies for you and notify you when you have new dependencies or new vulnerabilities in your dependencies. And we'll talk more about this later on, how some of that, all the areas that we plug into, but just being able to point this tool at your repos in GitHub or in Bitbucket, or to point it at your Docker images, or as you see here, even Kubernetes, and starting to give you that visibility into those environments and understanding them from a vulnerability perspective. And the other thing that Mick mentioned a little bit here is what Snyk does in terms of helping your developers address these vulnerabilities. And it's really centered around how do we provide you actionable tasks that you can complete simply to fix the vulnerabilities in your code. And not only do we fix them in your code, but we automate that ability to now send that fixed pull request back to the maintainer of that package. So who's maintaining the package as part of your dependency, we can automate sending that fixed pull request back to them. So not only is it fixed for you, now it gets fixed for the entire community. And so we're helping not only address vulnerabilities in your software, but we're helping address vulnerabilities across the open source community. So getting that level of ability to just visualize vulnerabilities and address them early on in the DevSecOps lifecycle, and in a way that developers are able to easily adopt, is critical. But it doesn't end there. And so I'm going to turn it over to Will now. Will's going to kind of talk to you a little bit more about how do we continue this all the way once we've deployed our applications and really ensure that what we've got in production is constantly monitored and constantly being protected.
Hey, thanks, Alyssa. That's great. Do you, I think the polling question's next. So.
Oh, I'm sorry.
Will.
Yeah, if we could advance.
Yeah, so let's do the polling. I think Alyssa had a polling question to ask you all, I think. Am I now in control, Alyssa?
Yep.
There we go. Okay. You should be. I'm waiting for you to control, I think.
Yep. It's taking control.
Brilliant.
So apologies, folks, for the technical difficulties here. Hey, Mick, there. All right, so I apologize. So David, here's just really quickly, these are just some of the areas that Snyk is able to plug into from an ecosystem perspective. And so from the question perspective, what I want to ask you about here is, what level of visibility does your organization have into those external dependencies? So are you doing anything at all? Are you cataloging those direct dependencies? Do you have something today that lets you catalog that full dependency tree? So if we can go ahead and pop up that poll here. So as you guys are working on your answers to that, you've seen the challenges that this creates. And I mentioned this idea of a software bill of materials before. And this question goes exactly or directly to that particular topic. Just the ability to really develop an overall understanding and that visibility into what those components are that make up your application. And so I'm going to be very curious to see what the results are that we get here and what people are doing about that today, because oftentimes what we see is that this is an area that doesn't have a whole lot of visibility for organizations, and it's a challenge that a lot of us have to face. So let's see where we're at here.
I suppose the other thing to mention, Alyssa, is that it seems to me that vulnerabilities have taken on a different kind of focus in my view over the last few years. I mean, vulnerabilities have become valuable. People want to find them. There's a lot more people hunting for them, and open source libraries that have been around for a few years might be a great place to look for vulnerabilities on code that was written maybe 5, maybe even 10 years ago. Is that something that you kind of agree with?
So that's one. I mean, there's actually, so the ability to measure the health and the overall security posture of open source vulnerabilities is something that's actually a subject of a lot of discussion, because there's a lot of different characteristics we can look at, excuse me. You can consider an older package that hasn't been updated in a long time. Yeah, that might very well have issues. And it might also be that it's that widely used and hasn't changed, so new vulnerabilities haven't been introduced to it. So it's actually a really complex question, but it is a really good question as well, and something that we can talk more about. Did we get results from that poll?
Not yet. I think they're working out of the background. But we can, yeah, there may be an issue in the background. So, Will, I think you've got control now. If we
no worries.
Continue.
Yep, thanks for that, Alyssa and Mick. Okay, so as Mick mentioned, what I want to cover off is vulnerabilities and code in general, just somewhat expanding on what Alyssa's just covered off. So what is a vulnerability? As we most probably know, it's slow on the screen, it's a flaw in code that creates a risk. So how do we reduce our risk? Or sorry, how many flaws do we typically have in an application or an operating system? Industry average is between 50 and 50 errors per 1,000 lines of code. So for example, Fedora 9 came out in 2008 with 204 million lines of code. That obviously introduces the possibility of millions of errors in that operating system. How do we reduce our attack surface? Well, as Alyssa mentioned, we first of all scan our third-party libraries, because at a minimum, no matter how unique our applications are, they make third-party libraries make up 80% of our code base, 80 to 90%. So by starting our scans there, we're able to close out a lot of the vulnerabilities that exist. Furthermore, another way in which we can reduce our attack surface is, as Alyssa mentioned as well, is through containerization and technologies such as serverless, or collectively known as microservices architecture. However, as Alyssa also mentioned, there is no silver bullet. As we saw in the node Docker image, I believe there's around 500 vulnerabilities that resided in that Docker base image. So although we're using Docker and we have very thin operating systems or base images running our applications, we're still not immune. Furthermore, even if we're using serverless, where by name you may think that there is no server running, we still are vulnerable. And so that misunderstanding can leave us susceptible as well. So the two main things that I want to touch on is that vulnerable code still exists, whether we're containerized or we're in a serverless environment. And if we don't configure or secure our cloud environments, we're just as insecure or just as vulnerable as we were with on-prem applications, if not more so. Okay, so I love talking about serverless. I find it very fascinating, and I also find it interesting that a lot of people believe because it is serverless or ephemeral, meaning that it comes and goes as required, they believe that there is no way in which they can be attacked. But as I just covered off, through things like vulnerable code or vulnerable writing of code, we can still be exploited. For example, what we see on the left-hand side of the screen is a nefarious actor. What they're doing is uploading a malicious payload to our Lambda, a Python Lambda in this example, saying, send me your proc self environs file. The Lambda believes this is a normal request, and it sends through the environments file. In case you're unaware, what's in the environments file is our environments variables, and that means that our AWS API keys have now been sent to that nefarious actor. Now, a lot of us, when we're playing with new technologies such as Lambda, we just want to get our little function working. We're trying to understand it. We're trying to learn it. We know that if we secure too early in the process, our Lambda's not going to work because we're just trying to figure out how this whole thing comes together. Therefore, there's every chance that our Lambda has a lot more permissions than it actually requires. It may even have full admin permissions. So there's a chance here now that this nefarious actor has admin credentials for our entire AWS account. However, if we did lock down our IAM role, maybe the credentials only allow access to a subset of our account. The fact of the matter is that Lambdas often, or serverless functions, often talk to a DB. So at a minimum, this nefarious actor is going to have read or read-write access to our database, which is, of course, what we don't want. In regards to cloud misconfigurations, 99% of cloud misconfigurations go unreported. That's for multiple reasons, but the one that most comes to my mind most frequently is the fact that, again, it is quite new to a lot of us. So we may deploy higher credentials that are actually required just to get something to work, or just to play around, or just to get my new RDS instance speaking to my EC2 instance, so on and so forth. The problem is that if I don't actually learn how to close off these security gaps, or if I simply forget, given that I may have 1, 10, 100 accounts in my AWS environment, I've now left a security gap in my deployment or in my company's AWS accounts. And therefore, the nefarious actors can easily scan the internet, scan my environment, and find these vulnerable assets and exploit them. So what do we do about this? Well, I'm sure we've all heard the term security is everyone's problem. I know that it's been thrown around a lot, and the way in which we can avoid that is by making it or coming together and working together, but it's not as easy as it sounds traditionally. We have our dev teams that are dev experts. We've got our security teams that are security experts. Neither one fully understands what each other does. For example, if we're using containers, if we're using serverless, Kubernetes, all that sort of thing, our security team may not even have heard these terms before. Likewise, our dev teams, or our DevOps teams especially, we love to roll out new functions, new features, new code ASAP, and unfortunately, we don't give too much thought to the security side of things. So how do we make it security everyone's problem? Well, to enable security, it needs to be non-disruptive. Again, DevOps or dev teams, they hate to be slowed down. So we need to ensure that it's easy for them to implement security without slowing them down. It needs to be simple to implement. Again, we don't want to slow anyone down, but we need the security to be fully featured in that we're not compromising security for ease of deployment. Finally, it needs to be easy to understand. Again, our security teams may not understand what Kubernetes is, what serverless is containerization, infrastructure as code, so on and so forth. So it needs to be very secure, but it also needs to be very easy to consume so everybody is kept happy. So what's Trend Micro doing in this space? What we have recently released is a tool or a solution called application security. As we see in line 1 of this source code here, it's a Django web app. We import the Python library into our Django web app, and immediately we have anti-malware protection. We have protection against OAuth-style vulnerabilities, open redirects, SQL injections, all through a single import statement. And so that feeds back to what I was just mentioning before about easy to implement, and the easy to view is as we see on the screen here. So I'll just pop back to the previous screen. Here, we're not standing in the way of our security teams. All we're asking them is to implement a single import statement. They're not refactoring their applications. They're not doing anything more than just importing a single line. In regards to our security teams, they get a nice simple graph that tells them what's happening. Are they getting malicious payload attacks? Is the application open? Is it getting affected by open redirects? Are there remote code execution attacks occurring? We don't see this screen here, but what it does as well do is gives us a full stack trace of the attacks that come through or that get prevented. So we're not only giving a easy to consume report for our security teams, but we're also enabling easy to implement solutions for our development teams. Furthermore, through the stack trace, we're also enabling our our application teams to close out security holes, which they may not have known existed at the time of release. So the way this works hand in hand with Snyk is that Snyk will do your pre-runtime protection, and this application security will do your runtime protection. In regards to cloud misconfigurations, you may or may not have heard that late last year, Trend Micro acquired Cloud Conformity. Basically what it is a tool that you pass in you create a CloudFormation template or you deploy a Azure template. It automatically gives us read access to your metadata in your cloud environments, and we automatically scan all of your environments for misconfigurations or things that you need to be aware of. For example, is two-factor authentication enabled on your root account? Are your security groups more open than they need to be? Is your S3 buckets open to the world, or does the world have read-write access, so on and so forth? Very, very easy, again, to deploy. It's a simple CloudFormation template for our application or cloud teams, and very easy to consume for our security teams, as we can see on the screen. So again, what we're doing is enabling security to be everyone's problem, and when we all work together, we're all able to ensure a more secure environment for our organization. Okay, so what we'll do now is present another polling question. Where do you feel is the most critical place for security to be implemented? At the perimeter, on the host OS, or within the application itself? Alex, if I can get you to bring up the polling question now, that'd be great. Thank you. I find this question a very interesting one. At the start of my career, I was a network engineer, so my original answer may have been at the perimeter. However, you hear about Apache struts getting attacked and the like, so perhaps I want to have protection within the application. However, OSs, Linux, Windows, whatever it may be, they're very bloated. There's a lot of code there, so perhaps I want to protect my host OS instead. So there is no right or wrong here. It's a fascinating question. It'll be interesting to see what the results say.
I guess the key is what's most critical, I guess. Wow.
Yeah. Within the application. Okay. Very, very interesting.
So that's 68% within the application and 21% of the perimeter. Yeah, fascinating.
Great.
Excellent.
All right, Mick, I'll hand over to you.
Thank you very much. Okay, so I think so what we presented to you, thank you, Alyssa, thank you, Will. I think what we've tried to present you with there is a view of some tools that Snyk and Trend are bringing to the table, and our partnership. So both companies are very security focused. They want to fix the vulnerabilities. They want to find and fix the vulnerabilities in your code, in the stack. You know, it's what Trend does across the board, in fact, and it's what Snyk are world leaders in terms of finding that. This slide is about how the two are working together. So I'm going to open this out to Alyssa and Will in terms of, let's talk about what Snyk are doing on the left-hand side and what Trend are doing on the right-hand side. So first of all, Alyssa, so could you just talk us through the dot points there on the left-hand side in terms of the collaboration?
Yeah, and so what I really want to do is kind of take this opportunity now to elevate the conversation a little bit. You know, we'll talk quite a bit about some of those key aspects, and Mick, you introduced them early on, the things that we need to be looking at when we look at how to adopt DevOps, or more specifically, a DevSecOps culture. Let's face it, we're talking security here, and to get security injected into this DevOps culture is something that we've struggled with. And part of the issue has always been, how do we speak to developers and how do we get developers enabled so that they can adopt the things, the practices we want them to do from a security perspective? Will touched on this quite a bit. He mentioned the term frictionless. You've heard that a few times. You've heard the words enable. These are things that are important when we start to talk about DevSecOps. So when we look at tools like Snyk, for instance, where it's plugged into all the tools that they're already using. We'll talk in a few minutes about some of the integration points, but from the IDE to the repos to the orchestration environments, all the way through to deployment, Snyk is there as a part of that, making it easier for developers who now have that responsibility to actually perform those security practices we're looking for and to take care of security early on. So it's not a matter of the security team, as it were, coming in later on and trying to dictate how security needs to be implemented or identify vulnerabilities as a last step before we go to production or things like that. Instead, it's enabling the developers and it's giving them tools that they can adopt easily, as Will said, without causing that friction, without standing in the way of their development. So when we look at that from that Snyk perspective, yeah, it's those integrations. It's integrating into all those developer tools, being able to handle all those different languages you saw earlier in those various ecosystems that are very popular with developers, and they're the ones that we're seeing in use most often. But then it goes beyond that. It's this ability to automate those fixes and to send those fix pull requests back to the package maintainers, so that we know not only are those developers fixing our apps, but they're helping ensure that if those dependencies exist elsewhere in our apps or within the ecosystem, that those vulnerabilities get addressed. And so this is how we build tools that developers want to use in terms of security, because it just makes it easy.
And it's pulling I guess it's pulling everybody up, right? And automation is an important part of that. And so that's great. You know, we've got on that side of things, we're producing what should be secure code. So, Will, that's enough, right? We're done. Job done. Or
well, no, not really. So,
okay.
Yeah, sorry. Go ahead, Mick.
No, you go. Tell me why not.
Well, yeah. So it's fantastic to scan in the pipeline, which is exactly where we integrate with Snyk, as well as the ongoing security is where we need to be as well. So as Alyssa mentioned, vulnerabilities that we know of today is fine. So we'll protect against those. We'll close out those issues. But at runtime, what do we do then when a new 0 day is found 6 weeks after we've deployed? And so that's where Trend Micro comes along with the Rust protection, the deep security, hybrid cloud protection. We're basically, through a single agent, we're able to deploy anywhere in the world, whether you're in GCP, AWS, if you're on-prem, you're bare metal, virtualized, Kubernetes. It's a single pane of glass, single agent that will protect all your workloads. And that's a problem that I've often found with security. We all want it, but we end up with tool sprawl. We've got different tools for different needs, which then makes security very difficult to administer. So it's nice to have a couple of products that will protect you from pre-runtime all the way into runtime, vulnerability is discovered at runtime. Okay, let's go ahead and fix that issue with our Snyk integration, with our Snyk assistance, put that back through the pipeline, redeploy the new application. So it's actually a holistic, you need a holistic overview in order to have proper security of your applications.
Great, and I think that the thing about all of these tools is that we're trying to aim them at developers as well as security people. So they're tools through which you can communicate. So let's move on. Let's move on to the next slide that talks maybe about how it really looks. So if we look at this slide, this represents your pipeline on where we're sat. So on the first of all, your code level there, you've got Snyk doing testing and fixing for vulnerabilities in the code. You can include the library from Trend Micro for application security to look for application issues, OWASP type vulnerabilities and that kind of thing. Obviously, Snyk then is constantly represented and fully integrated in that DevOps pipeline. And Trend has some stuff it can add there too. But then I think on the runtime protection, which Will talked about, when it's actually running on a container, or maybe a traditional server, or maybe in serverless, you can still think about network protection, OWASP style, WAF capability, IPS capability. We can run that in AWS and that kind of thing. Obviously, in the stack, thinking about security in the stack and agent-based security on server workloads, and then container-based security for actually your container environments. And then I think overall, the big circle around all of it with in the top left is about monitoring your cloud security for misconfiguration, and that's the cloud conformity tool. So I think we're trying to talk about 3 tools here that can help you bring together the DevSecOps community around shared responsibility for security in those areas. To go back to the poll that we had at the beginning, 70% thought security was development's responsibility. 29% thought it was, security was security's responsibility. I guess our view is that it has to be shared across everybody, and you need tools and capability to be a stakeholder in that conversation. So, Alyssa, do you have any thoughts around that slide and what I've just said, and particularly around the security gate? Actually, I'm interested in what your thoughts are around that traditional security gate. And that security gate's still there, right?
So I'm glad you brought it up. I'm glad you brought that up, because that is something that I want to address. Because anybody who's in development, myself, a former developer, still, to some degree a developer, even though I'm now, very much been embedded in security for the last 15 years. You see that idea of a security gate, and especially in DevOps, it's like, oh my God, that's sacrilege. We can't say those things. We can't have security gates. The problem isn't security gating. The problem is the feedback cycles from those security gates, right? So traditionally, security gates were, well, we do this pen test before we go to production, or we do some code review before we go to production, and if there's vulnerabilities, we spin it back around and you have to do more development before we let it go to production. The key here is when you combine some of these solutions and you've really built this DevSecOps pipeline where you mentioned my favorite term, by the way, shared responsibility. And it's not just shared responsibility for security. First of all, let's make it clear. The dev people, the sec people, the ops people, they are all responsible for building software quickly, that's secure, and that's stable. So everybody's responsible for all of those aspects. And so when this is all built into that DevSecOps pipeline, now you still have that gate in so much as, we don't want to throw vulnerable code into production. Nobody wants to do that. But when we've been building security in all the way, first of all, not only have we addressed the vulnerabilities, we have that demonstrable evidence that we've addressed the vulnerabilities. And just in case, we've got that insurance policy of all this runtime protection from the Trend side. when that stuff is deployed in our production environment and we launch those Kubernetes clusters, or we launch into that serverless environment in a cloud in space, we know now that we're protected even if a vulnerability shows up later on. We've got Snyk out there monitoring our open source dependencies, making sure that if new vulnerabilities show up in any of those libraries, we can address them. But in the meantime, we've got that runtime protection that keeps us safe until we can go ahead and run that next story through the backlog, and it goes through and sees that development and is implemented and deployed to production.
Excellent, thank you. I guess the other thing is, from Will, your side of things, we've heard about all these wonderful tools, right? So that can help developers, security, operational people get a better picture of the security status and the framework. What's your advice about what can I do next if I'm going, oh, okay, I'm not sure that my AWS cloud usage is secure, for instance, or yeah, I would like to know whether my application code has OWASP vulnerabilities in it. What would you advise as the next thing to do for somebody?
Sure. Well, I just advise them to give these tools a try. They're very easy to implement. They do have free trials, so just have a look at what it finds and see if it gives you anything interesting to consume. It may not, but the best thing is, even if it doesn't give you any interesting findings, at least you can rest assured that you've been doing the right thing, that your application's safe, your environment's safe. If it does find things, well, then it's great because it helps you close out those security gaps that we've been talking about in this discussion.
Yeah,
and so I want to add on to that, Mick, real quick, just want to add on to that because so we are talking about that ability to use these tools for free. And one thing that I do want to point out there, just because I heard the word free trial, and when we talk about Snyk is available to be used for free, period. Our freemium version, if you go out to the Snyk website, snyk.io, and sign up, you can point this at your Git repository, at your GitHub, your GitLabs, or your Bitbucket repositories, and run Snyk against your existing code today, and you can continue to use that. Those 440,000 developers you mentioned before, Mick, that's exactly what they're doing. Yeah, and we do have the pro versions for those enterprise organizations. But to get started, go out and just sign up for the free version, run it, and see what it shows you and the visibility that you get.
So, and I guess the additional challenge that I would add to that is, sure, go and look at the tools, but see if you can choose somebody else from your organization to go and look at the tool with. So if you're a sec person, see if you can get a dev person or an ops person to go, hey, should we look at this tool together? Because I think in my discussions with customers around these tools, it's not just the tools doing the job that the tool does, but it seems to be that within that shared responsibility, these can create platforms where stakeholders and teams can communicate around the challenges and do reporting of their own and understand their security maturity or what the gaps are, and they can understand that across the board. So, I mean, I think that would be my challenge. I don't know if that's if that's possible, but in terms of a real world situation, that would be what I'd say. What do you reckon, Alyssa?
Yeah, absolutely. And when I talk to organizations that are really good at doing DevSecOps, so a few that I can think of off the top of my head that are well recognized, organizations like Auth0 or Netflix or Envision, these are companies who are very, very advanced. And one of the things that they focus on is that interaction and that kind of meshing of responsibilities across the security and the developers and the ops folks. And so, yeah, as a security person, if I was to take this and I want one of my developers to try it out, yeah, I would want to sit down with them and say, hey, let's check this thing out. It's free. Let's pick a Git repo we can point it at, and let's sign up and let's see what it comes back with. And we can start to explore those results together. Just that ability to walk a mile in their shoes, as we say. or just understand, okay, what problems does this solve for our developers? And it's, I'm kind of laughing because I see Edward popped up here and says that they're already using Snyk on their Git repos and in their pipeline. So that's awesome. And that's the kind of reception you want to see. You want to see developers who are very happy that they're using these tools that are making their lives easier and making them more secure. As a former developer, I have yet to meet a developer who doesn't care about their code being vulnerable. It's just most of the time that security piece is only one component of a much greater set of responsibilities that they have to be concerned with. So if you can make it easy for them to make their code secure, developers like that an awful lot.
Absolutely. Yeah, I agree. And just getting that conversation happening across the organization is really important. We did talk a bit about automation. We have time for Q&A, so if you can all hear us, if you've got any questions about anything we've said today, or there's any confusion, please put your questions in the Q&A, and I'll mention them. You're right, Edward just mentioned we're doing this already, so that's awesome. Thank you very much. I guess we haven't talked very much about automation and multiple releases a day and the challenges of scaling. So I guess, in terms of all of these tools, and Will, maybe you could talk to this a bit. What would you say in terms of integrating the tools that we're talking about into the pipeline or into your coding pipeline and how they report? Is that possible? Are we driving things to our APIs? How does that work from a trend point of view?
Yeah, sure. So it's a very interesting thing. Security has always been thought of holding up a stop sign. Whenever you're developing, whenever you're releasing, you're creating infrastructure as code, whatever it may be, it always feels like security is stopping us. However, through these integrations, through Trend and Snyk APIs, all that sort of thing, it's showing that change in culture, that change in mindset, where security is everyone's responsibility, where we're now empowering our devs to use APIs, which I never thought I'd see for quite some time to come. So now we're allowing them to, or we're enabling them to interact with security tools the way that they've always interacted with all their other tools or their microservices or applications and the like. So that's really cool stuff. But furthermore, by having APIs, if there's not an integration that exists that you need, you can simply write it yourself. So if you want to integrate into your pipeline and you want that to send a SNS notification, which ends up being or triggering a Lambda function to send a SMS or whatever it may be, you can do that through APIs or SDKs and integrations as we see on the screen. So I just love that now security is coming towards the devs. And now through education and sort of joint teams, we're also enabling the devs to get more of a security mindset as well.
Yeah.
Alyssa, anything to add?
Well,
sorry.
I was just going to articulate that perhaps with an example. So the simple example I was thinking of was an S3 bucket that got opened up, and it was open to the world, or their permissions were insecure on it. And you could auto remediate that with APIs, right? You could pick that up almost immediately and secure that S3 bucket for cloud conformity. Alyssa, what's a similar sort of integration that you might see around automation and APIs for Snyk?
Yeah, so, I mean, you see them on the screen here, right? I mean, every one of these logos, first of all, they're all logos that your developers are going to recognize. So, we almost intentionally don't put the names on here because when your developers see them, they recognize these. They look at them and they say, oh, hey, there's Circle CI. We use Circle CI in our pipeline. Or they see GitLab, or they see GitHub, or they see, Bitbucket. All of these tools that they're using in their daily lives, they see represented up here. And so where we help with that automation is that we're tied in with those integrations. And so you check in that, your latest revisions into the repository, and there's Snyk already doing its job looking at your dependencies to see what's changed and what new vulnerabilities potentially exist. as we move through things like automation and our orchestration, we see Jenkins up there when we're moving into our build cycles and so forth. All of those components have integrations with Snyk. But then, like Will mentioned, all these products now, all these tools that we're bringing to your developers offer that capability of those open APIs, the Snyk command line interface even, where now you can tie that in. If there's an integration that we don't have yet today, your developers can create it on their own. They can customize it. They can use it the way they want. And that means so much. I mean, again, as a former developer, I can't tell you how much of a wonderful thing that would have been when I was back developing software and we were trying to secure it.
Perfect. Anything that can help you build the code securely is gonna be of great benefit. Will, going back to application security then, just from an automation point of view, you mentioned, we include the library that secures some stuff up. Maybe that could throw up an alert on something. How would that work in terms of a flow?
Sure. So what you do is, as we saw in the pipeline slide previously, you simply import the library into your code, pre-runtime, of course. You deploy that code anywhere in the world or on any platform you like. And then you have Trend Micro's protections from OAuth vulnerabilities, malware scanning on file uploads, so on and so forth. Now, when someone tries to do a remote code execution and your code is actually vulnerable to that attack, we'll block that attack. We'll give you a full stack trace of the exact line or lines involved that are vulnerable. And so from that, it's available on our console or through our API. So then what you could do is hook into that API, generate an alert through to Slack, which we have native integration for. But if we didn't, or if you wanted to integrate into some custom built tool, you can easily do that through the APIs, alert whoever needs to be alerted to it, and have them go away and resolve that issue. Or, for example, you could have it automatically create a Jira ticket or a task on Trello or whatever it may be. It's through APIs, again, I can't stress it enough, and I just find it so fascinating. Through APIs, we're able to automate a lot of things. And then I guess they say that we live in an innovate or die world. And basically, if we're not innovating rapidly, someone else will, and we could see ourselves losing market share and the like. So it's just very fascinating how through automation, we're able to innovate much more quickly than ever before.
Great. Thank you very much. So I think we're 5 minutes out from the end, or 3 minutes out from the end. Apart from Edward's comment about I'm using your Snyk stuff, Edward, I'd challenge you then to go and look at the Trend Micro side of that too. We haven't had any questions. Are there any final thoughts, Alyssa?
Yeah. So really, again, I just focusing on that DevSecOps culture story, right? When we think about DevSecOps, we seem to think tools, we seem to think processes. And in fact, if you go out and you look at Google Analytics, you'll see in searches that contain the word DevSecOps tools is far and away exponentially more popular than the next most popular query. And so the thing we have to remember here is it's bigger than tools. It's about the people and being able to connect our devs with our security people, with our ops people. We're giving devs that responsibility. And we saw it. You mentioned the poll results. And indeed, in our state of open source security survey that we did last year, we saw similar results. Everybody said developers were the ones responsible. And we set it up kind of like a trick question today. We left that other category there that they could select, but we didn't really lend to that. But honestly, the answer is all of the above. Everybody has that primary responsibility. If we're talking DevSecOps, we are talking that shared responsibility. So thinking about your tooling from a security perspective, is it something that a developer would use? And if it's not, then it's not something that should be a part of your DevSecOps pipeline. Look for the tools, look for the things that really speak to your developers, the things that make their lives easier. When I can write one line of code and I know that my application's protected regardless of, if I do miss a vulnerability somewhere, or I can plug a tool into my repo, and I know every time I do a commit, it's going to tell me right away if there's a new vulnerability that's been introduced. Those are the things that really make developers' lives easier, and that's how you get them to adopt your security practices when it doesn't impact their development.
Absolutely, and I think we're all singing from the same hymn sheet there, because we do also try to make sure our tools are frictionless. I'd throw this challenge out to the audience: is if you're not using all of these tools, so the Trend Micro app security, the Trend Micro cloud conformity stuff, Cloud One conformity, and the Snyk pipeline tools, then do go out and look at that, try them out. If you find the friction, we're always interested in what the friction is, because we want to make them frictionless. So we'd love to hear back from you about why they don't work, they don't quite work for you. So that would be my challenge to the audience. Will, any final thoughts?
No, I think Alyssa summed it up nicely. Basically, DevOps is a mindset, it's a culture. It's not just about the tooling. If you can combine all those things together, then you're doing DevOps and DevSecOps correctly. But yeah, other than that, yeah, it's been fun. Thank you for your time, everyone.
Yeah, so I think we're on time now to wrap up. Thank you very much for everybody for staying with us, and we will send out, as I say, a link to the recording, I think some PDF of the slides, and also there'll be a few links there for you to try these, to click onto these tools and go and see them and download them and use them. I'll encourage you to do that. So thank you, Alyssa. Thank you, Will, for joining me today. It's been great to have you here.
Thank you
Thanks,
so
guys.
much. I really appreciate it.
Okay, thank you very much. Have a great day, everybody. Stay safe. Okay, bye now.